Okay. Hello, hello. Hello.
Hello, hello.
Okay. I think the audio is right.
Hello, hello, hello.
Okay. I think the audio is right. Let me check on my phone once. There's a lot of background noise. Let me see.
There's a lot of background noise. Let me see.
Hello.
There's a lot of background noise. Let me see. Hello. There's a lot of background noise. Let me see.
Hello. Okay. Can you hear me?
Okay. Can you hear me?
All right. Let's go. All right. So what we are doing today is we are building. Okay. Let me change this title.
Alright, so what we're doing today is we're building
Output voice agent. Okay. So based on my research till now, there are two primary frameworks. One is PipeKit and one is sorry, not PipeKit, it's PipeCat. Okay. All right, let's go. So based on what I've researched, livekit is much better than PipeCat. Basically, I tried both of their starter kit, and livekit starter kit is much easier to like make changes and transform it into a real project because it gives you both the front end and back end as a separate starter. So we will go with livekit. Maybe in some future we can try Pipecast, building a voice agent using Pipecast. But today we're going to go with livekit. So let's see. Okay, what the hell is going on with my internet speed? Internet speed looks good. Why? Okay, let me just try this again. Is my system slow? Let me also see that. Okay, yeah, much smoother. Yeah, now it is working fine. Alright, cool. So we are livekit. So livekit is basically a framework that has taken care of a lot of things that is required in a voice agent. So to give you an example, the it's Scalidraw. So let's make Scalidraw. Okay, so first one is our speech to text. Okay, clearly I don't know how to use this, so let me just try this again. Okay. I thought it was pretty simple. I should have like figured out all this stuff before we started working, but let me just okay. Start with, pencil. Can I oh, okay, teardrop. So we have a speech to text, then that gets into our LLM for reasoning, and then we have our text to speech. And let's also show user input here. Let's- So we have an AI output. Okay, so that's the basic stuff. Now, for speech to text, there's a lot of stuff that goes into it. So, for example, uh, so when you are speaking in real time, right? So, first of all, we need to make sure that the latency between this whole process, this whole process is this whole process is under 800 milliseconds. More than this, the conversation will not feel natural, and this consists of a lot of steps. So a lot of voice agents have a latency of around 8 milliseconds. There are a lot of companies working on reducing this, but right now this is the benchmark that you need to have to make a good voice agent. Let me just check the stream if it is working. To make a good voice agent, this is the benchmark that you need to have to make a good voice agent. Let me just check the stream if it is working. Is my voice too echoey? Testing 1 2 3. Testing 1 2 3. Okay, I'll just assume that it is better now. Right. So now, if we talk about speech to text, right? So there's something called as turn detection. I think we're going into an advanced topic, but let's discuss it. I've recently been studying about this. So basically, what turn detection is that, like, when we are speaking to an agent, there are certain scenarios where so traditionally, how voice agents detect that it's time for them to speak is they keep a delay of silence. So, for example, I am speaking. I ask a question. Okay, what is the capital of? What is who is the Prime Minister of India? Right now, when I stop saying, when I said who is the Prime Minister of India, now it will wait for some predefined seconds, and if it does not get any other input from the user, it will then fire this whole process of converting speech to text, LLM, text to speech, and AI output. But if it detects that the user is still saying, it will not proceed. So that is to make the conversation as natural as possible. Now the challenge with the silence thing is sometimes user have silences in their conversations because they are thinking. So if I'm thinking, like right now, how I'm taking breaks while speaking, that's how normally humans talk. And if you consider any value, if you increase the delay by a lot, then even if you ask a question, the AI will take a lot of time to reply, which will not feel natural. And if you make it very small, there will be constant interruptions, because while you're speaking, you will take pauses and the AI will start talking and it will not feel natural. So to improve this, a lot of companies, what they're doing is, instead of taking silence as the indication of taking the next action, what they're doing is they're taking the words that are being spoken, they're taking that, passing into a LM model to predict what the user is saying, to basically understand whether what the user is speaking has it completed or not. So for example, if I say something like, what is the city of so since because I said and the thing that I've said till now does not make an actual question or like even a statement, the AI will wait till I complete it. A good example of this, I think I saw in Cartesia or Deep Learn. Let me just see. is Nova. No, it's in deep gram, I think. Nova flux. Flux. So yeah, so let me show you. Okay, so I am speaking right now. Hello. Is it not able to detect my audio? Hello. Listening. Are you able to hear me? This is a basic test to see whether it is listening or not, but it shows it's not listening. I've tried this before. It works. Hello. Hello. I was trying to take my microphone audio, but are you able to hear me? Why is it not working? Then let me just show you the demo.
Alright, I'm excited today to give you a demo of DeepGram Flux, action, LLM solutions, bolted on turn detection model. So you'll see as I start talking, all of these models will begin transcribing, and with Nova 3 and GPT, you'll see that it's really doing that caption-like transcription where it's transcribing everything I say, and these interim results are finalizing and moving up here. But on the left, you'll see something different with Flux. With Flux, you'll see that we're on an ongoing basis calculating the confidence and probability that it is actually the end of my turn. And when I do reach the end of my turn, you'll see that this transcript finalizes and moves up with the entire turn transcript. And that's the magic of Flux. It's a fused model with turn detection that takes the entire context of the current turn and very frequently, very quickly, and accurately, it can determine when a speaker is done with their turn.
So yeah, that was the magic. I hope you got the audio as well. I'm not sure, so let me just check. So yeah, that was the magic. I hope you got the audio as well. I'm not sure, so let me just check. Okay, great. Good. Yeah, so and livekit is also doing it. Like I was just reading it today in the morning. So livekit is using something called EOI turn detection. Let's see. End of utterance. No, not this one. Turn detection interference. So here's it, like user speech, speech to text, end of utterance, and then end of turn. So this is a great article to read, to see like uh, how what difference it makes. So rather than using silence, it uses they've created their own custom model for the task of predicting the end of user speech, which uses while a user speaking, their speech is transcribed to text using a developer specified speech to text service. Each word is appended to the model's context window for each final transcription received from STT. The model makes a prediction with a confidence level as to whether the trailing end of the current context represents the end of a turn for the current speaker. So, in simple words, what it is doing is wherever you are at this point of time, it is trying to see whether you are contextually have you completed the sentence, and the model basically gives a confidence score, and based on the confidence score, you can configure it whether you want it to go to the next step or don't want to go to the next step. So basically these are the values that you need to like modify to make it more accurate. Got it. So we'll start with that is so that was turn reduction. There are other things. I think we will. There's a very good. I want to like point out. There's a very good article that talks very deeply about voice AI and voice agents. I think this is something that everyone who is getting into voice AI should definitely read. I'll try to add like resources. So if you want all these links, comment, and I'll add all these links in the description box. All right. Okay, I'm not going to read through all of this. Let me know if you want. We can like do a reading session together. But right now I've already read through this, and I understand like 80% of this whole thing. I understand a few concepts much better now compared to before. So yeah, great article to read. It also talks about scaling and like memory and a lot of evals. These are some things that I'm not really good at. So I will definitely be coming back to it again to go through them and get more understanding. Good. Here it is talking about latency. Okay. We'll take a 2-minute pause. I'll just get some water and then we'll continue back again we'll start with building the agent. By the first step would be if I can. Okay, let me just let's simplify it and a lot more. Okay. Okay. Stop listening. Okay. Start building. Okay. I've already signed up. So basically, you can use settings and API keys to get your own API key. I don't think so. We need to do anything from here right now. We need to go to the docs and set up the starter project. Okay. So let me just search for livekit docs. Voice AI quick start. Build your first voice agent in less than 10 minutes. Okay. Python starter project. Okay. Okay. So we'll just clone this. Okay. Okay. So we'll go in. I'm just opening up the right folder I want to clone this in. So we'll go in Python projects and we'll go git clone. Okay, not this. Git clone and let's go like it. Okay. See the agent starter Python and we're gonna open our cursor. Okay. Let me just open up my terminal here. Okay. So if we go to agent.py, I think it has already given us a scaffold, or basically like it has written all the code that is required to do this. And all we should need is the API key for livekit. Let me just see. Okay, let's just follow the tutorial, right? They're already doing this. Okay, let's UV sync. Okay. I think if you don't have UV, you will have to install it. So you can go install UV, or let's just see how we can install UV. Install Python UV. Click install UV. Okay. What is UV? Good question. What is UV in Python? Showing us the arrays. Okay, UV in Python. I was expecting like a good answer. I don't have time. Text. Yeah. One package and project manager written in Rust programming language. This is so it is a package that someone created, and basically it will replace all this. So let's see what has happened. Okay, so UV sync has worked. Next thing we need to do is we need to add. Okay, let me come back. So after we do UV sync, we need to create .env.local file and add these files. I'll do that right now. So I don't see the .env example. Okay, I see. So we'll basically duplicate this, or we can rename it also. So let's rename this .env.local. It already has. All we need to do is put the values. So I'm just going to do it in secret because I want to expose my keys right now. Okay, so we are back. I've already updated the .env file here. I'm going to close this. Yeah, so I don't want to accidentally open it. I've added the livekit API key, which you can get from here API keys. Okay. So after this, I think next step is to run. Okay. You need to run. Before you first run, you must download certain modules such as Silverware, WAD, livekit turn detector. Okay, let's also read more about this. And we'll, in the meanwhile, we'll just let it run in the background. Silverware plugin. Silverware plugin provides voice activity detection that contributes to accurate turn detection. Okay. So this Silverware helps in turn detection. Livekit recommends using Silverware plugin in combination with custom turn detector model for the best performance. So basically, what it's suggesting it to use this Silverware plugin along with livekit's their own custom turn detection model that they provide. Okay, we'll come back to this. I think contact is kind of turn detection. Initialize your agent session with the Silverware plugin. Okay, do you want to look through the code? So what we're doing here, import logging. Okay, and this is for importing the .env keys to the project. Then we're doing livekit import RTC. I think it is a short form for WebRTC because livekit uses WebRTC for transferring the audio packets. Then we are importing agent. Okay, agent server, agent session, job context, job process, CLI instance number, room ID, room IO. I think there's a lot of things that we don't need, but the scaffold it considers the basic scenario of creating a room and letting agents join in the room. So basically, I can actually create a room with two AI agents, or I can have a room with two humans talking, and the AI agent just acting as a note taker. So maybe in a future tutorial we can do that. Livekit plugins, front detector, multi-link. So from livekit plugins, we are using noise cancellation and Celero plugin. This is the VAD that we just saw. Noise cancellation is good. We don't want like background noises in our input that might affect the LLM's reasoning and also give like random gibberish output. So that's good. .ini local. So good thing about livekit is rather than like creating individual account on all. So when we talk about let's come back to this drawing. So when we talk about this 3 steps, each of these steps are taken care of by a different company. So for example, speech to text, the most common one is deepgram. So deepgram basically is used to convert speech to text. They do a very good job in converting speech to text. For LLM you can use LLMs. Okay, I'll just add examples. So for example, speech to text, deepgram is a good option. There are others. There's also Sarvam. This is for Indian languages, Indic languages, I think they say. Then we also have for LLM we have OpenAI models, GPT models, Anthropic models, DeepSeek, Llama, etc. There's a lot of models that we like commonly use. And then we also have text to speech, for which we have 11 labs, and we also have Cartesia. Now let's see what they are using in by default. So if we go down, you can see for STT they're using Assembly AI's Universal Streaming. For inference they're using OpenAI's GPT 4.1 mini, and for text to speech they're using Cartesia Sonic 3 mode. Okay, we can make changes to these models. They give a list of all the models that we can use. Okay. Okay, so let's go back to our starter project. We run Python. Next, run this command to speak to your agent directly in your terminal. To run this agent for your use front end or telephony, use the dev command. In production, use the start command. So right now we don't have a front end and also don't have a telephony. So we'll run it in the console and see how it does. Okay. So you will run Python. I think it's going to basically run this file and start the voice AI agent. The list files of like plugins Celero, finished downloading files, initializing process. Okay, finished downloading files, starting console mode, user selector, KQQ selector, starting worker, starting inference executor, initializing process. I think for the first time it will take time, but after that it's going to be pretty smooth. Hi, how are you doing?
Hi there. I am doing great, thanks for asking. How about you?
I'm good. I just wanted to know more about India and who is the current Prime Minister of India.
I'm glad to hear you're good, India. Thank you. I'm glad you're glad. Let me know if you want to learn.
Okay, so it did transform the text into who is the current Prime Minister of India. India is a diverse and vibrant country with a rich history and culture. That Prime Minister of India is Narendra Modi. But I think the text to speech kind of gave up. So let me ask you a new question. Give me a mathematical equation.
Sure here is a simple one. 2x plus 3 equals 7. Can you solve for x?
X is 4.
Almost close, but actually if 2x plus 3 equals 7, then 2x equals 4, so x equals 2. Keep going, you're doing great.
Okay, so I'm not able to read this text. I'm trying to just go based on the conversation. So let us try to. Okay, can you tell me a joke about LLMs?
Sure, here's one. Why did the large language model go to school? Because it wanted to improve its sentence structure and avoid getting lost in translation.
That was a bad one. Can you give a joke about voice agents?
All right, here's one. Why did the voice agent break up with the microphone? Because it found the conversation one-sided.
Okay, that was a good one. I can give it that. All right. Can you tell me more about livekit?
Livekit is a project by NPR that offers helpful guides and tips on a wide range of topics like health, wellness, money, and personal
Okay,
development.
I think that you're
It
mistaken.
aims.
I think you're mistaken. So let me just complete my thought.
Oops, my mistake.
Okay. Also, let us test turn detection. So let me just take a 5 second or 2 second pause and let's see whether she tries to complete my sentence. I am right now thinking I am going to. Yeah. Okay. She's waiting. That is a good thing. All right. Let me just end by saying, okay, where do Odisha fall in India?
Odisha is a state located on the eastern coast of India. It borders the Bay of Bengal to the east and is known for its temples, beaches, and rich cultural heritage.
Okay. Can you tell me what is the difference between VAD and turn detection?
Sure, VAD, or voice activity detection, is about identifying when someone is speaking or when there is silence or background noise. Turn detection is about figuring out when one speaker finishes and another starts in a conversation. So VAD detects speech versus no speech, and turn detection detects changes between speakers. Does that help?
Yep, it does. So that's there you go. Basically, like that is the simplest way to create a voice agent. We just create a voice agent. We are able to ask questions, and basically you can play along. You can try changing this prompt to make it do specific things. You can give it a prompt to act as an interviewer and practice giving interviews, or you can ask it to be a customer sales agent and try to pitch, and you can learn based, or you can ask it to validate your pitches. Okay, so yeah, there can be many use cases, but that was the initiation. The next thing we're going to do is, instead of running it in the console, we'll use the livekit, like the React starter project, to create a UI which also connects to this agent, and we will have a nice UI where we can like start the connection, stop the connection, see our text in real time, and all those functionalities. So that would be the next step. We are currently, can I see the time? Okay, we are 44 minutes in. Nice. So next thing we need to do is go into, so till this part, like I've already gone through the steps and I know that like what I'm doing. After we connect the front end and the back end, then the actual challenge starts. I have no idea where to go from there, but we'll figure it out. Okay, let's go to livekit examples. We must have a React one. Yeah, this is the kind of UI we'll see. So let's clone this project. I'll clone this here only. I can do cursor, agent, starter, React. Okay. For running this project, we'll run these two commands. One is pnpm install. It will install the modules required in node modules, and then we'll also run pnpm dev to start the app. And I think we'll need to configure the because we are specifying the livekit URL. If the livekit URL is same in both the Python project that we made and the React project, it connects to the same server. So we are using the same voice agent to interact. Just these are two separate projects right now that are connecting through this livekit URL. Okay, so npm dev, and while it is running, I'll also copy the .env file here. So I'll create we'll just rename. If you can see, I'm going to .env example. It already has these keys, so let me just rename this file. I will make it work. So okay, let's create a new file. Okay, so it has installed all the packages needed to install. Now what it's doing is it's going to start the React project. But before we do that, I think we need to specify the .env file, and we're going to make it .env.local, and we are also going to copy all this to this, and I'm going to go private window and just copy the livekit URLs and keys from my Python project to make sure that they're same. So let me go back. Okay. Yep. So this is the example. I've already added my key, secret, and URL in the .env.local file. Just replace these values, and now we are good to go. So let's just go to localhost 3000. Our Python project is not currently running. So you remember, like, we ran this command console. Instead of console, what we need to do is let me just show you. So to run the agent for use with the front end, we need to use the word dev. So we'll just, all we need to do is, we'll do, instead of console, we'll do dev. Okay, let me just get back. So we are here. What is the issue? I don't think we made any changes, so I think this is kind of a warning rather than an error. Let's just try the app, if it works or it doesn't work. I think I'm getting a bit of a lag because I'm running this live stream software called OBS. Let me just check whether I'm not running anything heavy on my system. Yeah. Okay, let's start the call with. It's going to ask me for permission. So okay, I've already given it permission. Agent is listening. Ask it a question. What is 2 plus 2? Hi, what is 2 plus 2? Can you hear me? Agent did not join the room. Okay. Alright, initializing process. I think we started the call a bit early, so I think creating agent session using audio room agent session transcript. I think like now the agent is ready. Now let's try again. Hi, can you hear me? Is it able to detect my sound? Hi, can you hear me? Oh, let me see.
Hi. Yes, I can hear you. How can I help you today?
Okay, can you tell me what is 2 plus 2?
2 plus 2 is 4. What else would you like to know?
Can you tell me a story about a rabbit and a tortoise?
Sure, here's a story about a rabbit and a tortoise. Once upon a time, a speedy rabbit mocked a slow tortoise for being so slow. The tortoise challenged the rabbit to a race confident. The rabbit took a nap during the race, but the tortoise kept going slowly and steadily. In the end, the tortoise won the race, proving that slow and
Okay,
steady
let's
wins the
just
race.
see if we interrupt whether they start listening. So I'm interrupting you. What I want you to do is give me a character. Like imagine a famous person. Don't tell me its name. I will ask you questions and you can only answer in yes or no.
Got it? I have a famous person in mind. Ask away, and I will answer yes or no.
Okay. Is this person related to a software company?
Yes.
Is this person rich?
Yes.
Is this person appeared on TV shows and movies?
Yes.
Is this person also have multiple companies?
Yes.
Is this person Elon Musk?
Yes, you guessed it right.
Oh,
It is Elon Musk.
okay. Can you think of some another person? Let's try this again.
Okay, I've thought of another famous person. Go ahead and ask your questions in yes or no format.
Is she a female? Oh, is it male?
Yes.
Is it related? Like, do they live in the United States?
Yes.
Are they active on social media?
Yes.
Are they alive?
No.
They're not alive. Okay. Were they alive in the 2000s?
Yes, they were alive in the 2000s. Keep going.
Okay. Are they an entrepreneur?
No, they are not an entrepreneur. Want to ask more questions.
Were they a scientist?
Yes, they were a scientist. Good guess.
Are you thinking of Stephen Hawking?
Yes, you got it. It is Stephen Hawking. Well done.
Oh, nice. All right. Right. So, guys, that was an example on how to use voice.
Looks like you're ready to chat with more people.
Yep. So that was the example of creating voice agents. Basically, we didn't code anything. We just played around with the starter kit. Now the real challenge starts. Now we start making changes into the code that has been given to us. The starter projects, how to connect them and how to run, I've already shown. All right. So in the next live stream, we're going to start with making changes and customizing this to our needs. So what we're doing is building a customer support agent. So we'll try to change the prompt for it to adhere to a specific use case, and let's see with that what all changes we make. So this would be interesting to see now, right? Cool. All right. Bye bye guys.